This video, more linear regression on a TI. We're down here in part 2, where we're going to calculate and view our least squared residual line, also known as least squared regression line or LSR line. So by this point, we've put in all of our data. So maybe, I guess I can even write that. Step 1, input data, see previous video. But once you have all your data inputted, I don't know, you can have your calculator calculate a least squared regression line. I'm going to put step 2 in here, and I'm going to specify you only need to do once. Do this once with your calculator, always be on. We're going to turn on Diagnostics. So kind of the idea here is when you calculate your least squared residual line, it doesn't give you all the information that it can. It only gives you a couple pieces of information. Some more information that's really helpful, you can tell your calculator to tell you, but to do that you have to turn on Diagnostics. And the way you do that is go into your catalog. So you hit second and then the key 0 to get to catalog. So what I'm saying there is if we hit our second key and then 0 here, you see we get this catalog button. And this lists everything your calculator can do. So I'll say scroll down to, I think it says something like that, diagnostic on. And then you have to hit enter twice. So what I'm saying is you can just scroll down until you get to the D's. If you want to kind of shortcut it, if you hit the key that has a D above it, it'll jump to the D's so you don't have to see everything. But you can just keep scrolling down until you get there. And there we go, diagnostic on. If I hit enter, it'll say diagnostic on. If I hit enter, it'll say done. So now my diagnostics are on. I never have to do that again with my calculator. It's default to always do that. Let's change colors here. Step 3. Let's calculate our LSR line. So to calculate your least squared regression line, what you have to do is you hit stat. I guess I should be keeping track of this. Stat, and then you go to calc menu, and then it's linear regression AX plus B. So I hit stat already, and then I want to go to my calc menu, so I hit to the right, and then I go down to linear regression AX plus B and hit enter. Stat, calculator, okay, then enter X and Y lists with a comma in between. So what I'm saying is earlier you put your data into a list. You put these X variables, your explanatory variables, into one list and your Y's into another list. If you have trouble identifying which is the X and which is the Y, go back to the previous video. But what I did is I put my X's in L1 and my Y's in L2. So what I'm going to do down here is say linear regression AX plus B. My X values are in L1, and then I'm going to hit this comma key, and my Y values are in L2. If yours were in different lists, input your list there. If you don't put anything in here, it defaults to L1, L2. So in this case, I didn't need to type that in, but I just wanted to be clear. Then you hit enter, and it gives you your least squared regression line. In this case, y hat equals 4.3 x plus 2.8. You can interpret these coefficients. This is our slope and our y-intercept. I'm sure let's go ahead and interpret them. This is saying if no snow, if my x value is equal to 0, we still expect 2.8 accidents. And this 4.3 is saying for every additional unit, every additional 1 that my x goes up, so every additional inch of snow, we expect 4.3 more accidents. And then you'll note that it also gives you two more things. It gives you R squared and R. These are two things that would not have given us had we not turned diagnostics on. So if you don't get these two things, go back and make sure you turn diagnostics on under your catalog. So let's see, R is called your correlation coefficient. Whereas R squared is your coefficient of determination. Coefficient, something like that. Not at all important that you know those names, at least not in my class. And what they mean, so this is a measure from -1 to 1, where negative implies negative correlation and positive numbers implies positive correlation. So what I mean by that is, in this case, my R value was 0.97, so that's a positive number. So that means I have positive correlation here. It means that as my X values increase, my Y values also increase. It means that more snow causes more accidents, not more snow causes less accidents. So this, whether it's negative or positive, tells you this, and closer to 1, maybe I'll say, or -1 if it's negative, implies stronger correlation. So in this case, we had a 0.97, which is pretty close to 1. So that means there's some strong correlation here between snowfall and the number of accidents. If this were a positive number but much smaller, like 0.13 or something, we'd say, yeah, there's positive correlation, but it's very weak, right? 0.13 is nowhere close to 1. So we have weak positive correlation. R squared, our coefficient of determination, that tells us it's a measure from 0 to 1. I don't know why the parenthesis is there, from 0 to 1. And it tells what percentage of the variance in Y is due to variance in X. What? Okay, what I'm saying is my Y value here, there's a lot of variance, right? This day there was only 6 accidents, this day there was 40, 30 some, 20. There's a lot of variance here. And the variance in this data is due to a lot of factors. There's a lot of different things that can cause car accidents. But one of the things that cause car accidents is how much snowfall there was on that day. And in this case, because R squared is 0.947, we say that 94.7% of this variance, 94.7% in the change in accidents that we have, is caused by the change in snowfall. Snowfall is a good predictor of accidents because this value is close to 1. So that is what your R squared tells you. We got R squared. That's just about all. What have we done so far? I guess we've calculated our least squared regression line. One last thing, I'm kind of short on room, but what I can do is view our least squared residual line. So should we? Yeah, let's do that now. Okay, so the last thing I'm going to do on this video, how long are we? 9 minutes, getting kind of deep into this video, is to view this least squared residual line. What you can do is just take your equation right here. We kind of want to view it on the scatter plot. You could just take this equation right here and hit y equals, got to turn my calculator on, hit y equals, and this will pop up. And you can type in 4.3x plus 2.8, and then it'll know to graph that line. But sometimes these numbers aren't as nice as these. They're really long decimals, or maybe you don't want to remember them and type them back in. There's a way your calculator can remember this line for you. And the way you do that is you hit stat, calc, linear regression ax plus b, so the exact same thing we did before when we were calculating our linear regression line. And then just like before, L1, comma, L2. But what you do now that's a little bit different is you put another comma in, and then I want to put y1 in here. So what I'm saying is I want to store my linear regression line in my first y equals thing. So the way you do that is you hit this variables key, and then go to y variables, and then function, and then y1. So when I hit enter, what it's going to do is it's going to store my linear regression line, this 4.3x plus 2.8, under y1. So I hit enter and it kicks out all this same information, but now if I hit y equals, I'll see that I got my linear regression line here. And the good thing about that is since I've already created my scatter plot, if I just hit graph, not only will it show me my scatter plot, but it'll also draw my linear regression line right on top of it. And so you kind of see that it's the line that best fits this data, that tries as close as it can to kind of go through those points. Really what it's doing is it's minimizing the sum of the squares of the residuals of each of these observations, hence the name least squared regression line. But we'll talk more about residuals in the next video, so I suppose that is the end of this video.